Hi, listeners. I'm Jeff Del Vizio, the Chief Multimedia Editor and Executive Producer here at Scientific American. I work every day alongside Rachel and Fonda and the rest of our crew here at SciAm to bring you science quickly. But before we dive into today's episode, I want to share something very personal and important. I spent the last 25 years of my life telling stories about science. I've written, filmed, recorded, and animated the discoveries that shape our world. Whether it's exploring science inside of biosafety labs or out on ice sheets, I've witnessed the power of science journalism. But here's the hard truth. Journalism like ours is getting harder to do. Newsrooms are shrinking, misinformation is growing, and responsible reporting, real, verified human reporting, takes time, care, and support. Subscribing to Scientific American is the best way to keep science journalism alive. By subscribing to SciAm, you're supporting the work we do to bring you science quickly. Please consider getting a subscription today at scientificamerican.com/getsciam/science quickly. As Thomas Jefferson once said, if a nation expects to be ignorant and free in a state of civilization, it expects what never was, never will be. I know we all want to live free, so let's keep learning together.
For Scientific American Science Quickly, I'm Rachel Feltman. It goes without saying that a lot has changed at Scientific American since our first issue came out in 1845. But the magazine and the world of science journalism in general also looks radically different today than it did in, say, 1990. That's when today's guest first started working at SciAm. Until his retirement earlier this month, Gary Stick served as Scientific American's senior editor of Mind and Brain Topics. Given that Gary worked at SciAm longer than I've been alive, we thought it would be cool to pick his brain about how his coverage areas of technology and neuroscience have evolved over the last 35 years. Gary, thanks so much for coming on to talk to us today.
Well, thank you for having me.
So when did you actually start at Scientific American?
I started in June of 1990. I was here largely before the internet as we know it now. We take the floppy disk, we create a printout, and that was used by the copy desk to actually edit the articles we were doing. And there always are corrections to a manuscript. One copy editor would have to read to the other the changes. So it was a very different world than the one we have now. To put that in context, there was an internet. It was used by the government and certain academic facilities, but the time of waking up in the morning and looking at your device was far, far away.
Right, yeah. And you started out covering technologies, is that correct?
Yes. Scientific American was in its absolute pinnacle of its heyday, was the whole period after the launch of Sputnik and the recognition that the U.S. had to up its game in science and technology. I can't tell you how many times that through the years I've met people who've said, I have every issue of Scientific American going back for 40 years. They're all in my garage. So one of the things I covered was the emergence of the internet, or it was actually a question of how electronic communications would provide things like entertainment, news, shopping. And at the time, it's so funny to think of this now, AOL was thought of as perhaps the leading contender for being able to do that, given the position of AOL today as a very, very minor player. That is absolutely hilarious. But the peer connections of the internet and the gradual evolution of thinking about how that peer-to-peer aspect could enable everyone in the world to communicate. I actually have a small excerpt from one of the articles that I wrote at the time called Domesticating Cyberspace. And it said the migration to the internet by universities, government agencies, community organizations, and even business electronic mail users is seen as stirrings of mass appeal for electronic networking beyond the automated teller machine. So the automated teller machine was thought of as high-tech, and very advanced technology was thought of as email, which is so ironic given everything that's happened in the decades since then.
Yeah. Now, I remember being at a science museum somewhere it was maybe at the earliest 1994, maybe 1995, and they had a little exhibit where they were like, this computer is connected to a computer in France. You can talk to France with this computer. And it was like, whoa.
Yeah.
So yeah, things have changed a lot. What are some other things that, fascinated you in the 90s in terms of technology coverage?
Well, I wrote a bunch of those trends articles, and they covered a range of technology topics ranging from maglev trains to the need for an upgrade of the air traffic control system, which still needs upgrading even after all of these ensuing decades. And I even did a story on designer concrete. In the late 1990s, I started a column on intellectual property, exploring questions like how to patent a gene, and looked at the development of new technologies from the original idea all the way to the market. One story was The Land of Milk and Money that looked at genetically modified goats that even today are used to produce antithrombin, a protein that has anticoagulant properties. Another of those columns was a sensor that could detect odors better than a dog.
And these days, your specialty is neuroscience. When did that start to be your beat?
During the 2000s, there was an editor who asked us to choose particular beats. And I had written an article on cognitive enhancement and drugs for cognitive enhancement, and whether cognitive enhancement, as the way people think about it, which is it possible to take your ordinary daily baseline and improve upon that and be able to think and interact better by taking a drug. And I did an article on that, and I also did another on whether conceivably in the future, would it be possible to upload one's brain into a computer? There had been a lot of talk about what's called the singularity, in which that might at some point become possible. In both instances, the answer to the questions that I was asking was largely negative. You can't upload your brain into a computer, and we really don't know how to do that. And also, the idea of cognitive enhancement is very overblown and overrated. So around the year 2010, I took on the neuroscience beat. The early years coincided with the emergence of what was called the Obama Brain Initiative, which was a recognition that a more formalized approach was needed to the study of the brain. More than anything, better tools were needed as well. There were basic questions that surprisingly were not answered, such as what are all the cell types in the brain? People didn't know whether there was a certain fixed number of cells of this type or that type. And that was one of the things that was being explored. Also, the wiring diagram, the way that the 100 trillion connections in the brain are connected together. That is a level of complexity that we still have not been able to parse. Ultimately, there will maybe at some distant date be a wiring diagram of the whole brain. But in the interim from the 20-teens, we've made some progress. There has been a wiring diagram, for instance, of the insect brain, but we are still very far from having a total map of all these things. There have been cell atlases that have given us information, but something as ambitious as documenting all of the connections and how they interact with each other is still pretty far in the future.
What have some of your favorite topics in neuroscience been to cover?
One of them has been what sometimes are called mini brains or organoids. These are clumps of stem cells that can grow into portions of the brain that are a component of the cerebral cortex, for instance. And the value of that is that they deal with some of the deficiencies of ordinary research in neuroscience, which is often focused on rodents. I mean, mice aren't going anywhere soon. They will always be a part of neuroscience research. But there is a serious attempt with organoids to make up for some of the deficiencies of just having mice to study. I mean, mice do not get Alzheimer's. So in 2017, we ran an article on organoids by a researcher named Jürgen Noblick from the Institute of Molecular Biotechnology of the Austrian Academy of Sciences in Vienna. And he explained how mouse animal models are really deficient in a lot of ways because the brains of mice do not have the corrugated folds that the human brain has. He explained it in an article like this. The differences, the folding, are differences that may explain why many common genetic mutations responsible for severe neurological disorders in humans have little effect when bred into mice by researchers trying to study the mechanisms of human disease. And organoids, they're actually really tiny. They don't know how to create a fully fledged brain, but having these sections of tissue can be really useful. Organoids have been used in studying a disease like Zika that was epidemic in Brazil years ago, and they were able to establish through the organoids' growth patterns that the virus can lead to microcephaly, which is an infant with a small head. That might have been just a hypothesis if they didn't have access to that tissue that they were able to grow into organoids. The question that always comes up with this is whether these organoids are conscious, whether they're sentient and are able to interact with the world. There are some tantalizing experiments that suggest that it might be possible to do that, but the answer to that is largely that they are not conscious entities in any sense. Noblick said in the article, the probability that a lab-grown brain will develop a mind of its own is nil. An organoid is not a humanoid in a jar and will not be one even in the far future. Any conscious being needs to be able to process information from the senses to develop an internal mental model of reality. Organoids are neither able to see nor hear and lack any sensory capabilities.
Well, speaking of the future, even if we don't have sentient brains in a lab, which I think is probably a good thing, what are some trends you think we might see come up in the neuroscience field?
There have been a number of advances like deep brain stimulation, which are carefully placed electrodes in the brain that have been a total godsend for thousands and thousands of people with Parkinson's disease. Moving to the future, that is expanding for things like depression and obsessive compulsive disorder. There have been demonstrations of brain-machine interfaces that led an ALS patient with almost no motor capacity to voice words from the person's thoughts. The holy grail for neuroscience is consciousness. It's one of the things that most intrigues readers, the idea of what actually underlies consciousness, whether in humans or a machine. There have been experiments in the last couple of years testing out ideas for consciousness, and there was a well-publicized bet between the neuroscientist Christoph Koch and the philosopher David Chalmers about whether there would be the neural correlates, the actual neural processes underlying consciousness about now. The neuroscientist Christoph Koch bet that there would be available to scientists an understanding of what underlies consciousness, and the consensus was that we have not reached that. That is a goal that will probably go for generations and generations before we understand that, because of the complexity, what's sometimes called the most complex machine in the known universe, to understand the emergent properties from a machine that has 100 trillion connections that are all interacting with each other. One of the preoccupations of neuroscience, science, and medicine in general is neurodegenerative diseases like Alzheimer's. And there has been progress during the past decade coming up with blood tests to diagnose the disease and drugs that somewhat modify the course of the disease. But this work is continuing, and there's no drug that approximate anything close to a cure. I actually covered some of this. I went to Colombia to write on a clinical trial of families near Medellin, Colombia, who had dominant genes that assuredly brought on Alzheimer's at about the age of 45. The trial was attempting to determine whether a drug that removes the amyloid proteins that build up in people with Alzheimer's would prevent the disease. And it turned out that it didn't, but it also marked a period when there had been progress, and there are drugs today that have been approved in the last few years that do help somewhat to delay the progression of the disease. And there's also been an attempt to deal with neuropsychiatric disorders, drugs like the SSRIs for depression or lithium for bipolar disease. These drugs are really old. They are decades and decades old. And there's a need to come up with new drugs. There have been some ideas that have generated a lot of excitement, like ketamine for depression. Ketamine is considered a psychedelic, but it's not like a classic psychedelic like LSD. There has been an attempt to try to use these for things like post-traumatic stress disorder. Recently, there was a trial on MDMA that seemed successful, but for a number of reasons, the FDA didn't approve that drug. So all of the psychedelics show a lot of promise, but they're not there yet. So that is still an area that's very much in development.
Well, thank you so much for talking through your career with us. It's been super interesting.
Sure.
And congratulations on your retirement.
Oh, thank you very much. It's been an incredible experience to work here. Thank you for inviting me, and I thank Scientific American for letting me stay and basically be in learning mode for 35 years. So thank you.
That's all for today's episode. We'll be back on Monday with our usual science news roundup. Science Quickly is produced by me, Rachel Feltman, along with Fonda Mwangi, Kelso Harper, Naima Marcy, and Jeff Delvisio. This episode was edited by Alex Seguiara. Shayna Pozis and Aaron Shattuck fact-check our show. Our theme music was composed by Dominic Smith. Subscribe to Scientific American for more up-to-date and in-depth science news. For Scientific American, this is Rachel Feltman. Have a great weekend.